Geometry, yeah, we are back again. Chapter 3, Section 2, parallel lines, and transversals. Okay, let's look at a few... what do we have here? Let's look at a few properties of parallel lines. Okay, so here we have parallel lines, and the transversal cuts through it. Notice we have a bunch of angles numbered. All right, first theorem. The corresponding angles theorem. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So corresponding angles means in the same place on the other line. So for example, angle 1 and angle 5, those are corresponding angles, so those two are congruent. So based on this theorem, here's an example. I could say, for example, angle 1 is congruent to angle 5 because they are corresponding angles. All right, theorem 3.2, alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Alternate interior. So for example, we have 4 and 5. Those are alternate interiors. So angle 4 is congruent to angle 5. They're alternate interior. Theorem 3.3, alternate exterior angles. Alternate exterior angles are congruent. So 8 and 1, for example. Angle 1 is congruent to angle 8 based on alternate exterior theorem. And finally, 3.4, consecutive interior angles are supplementary. Okay, they're not congruent, but they are supplementary. So for example, 3 and 5. Angle 3 plus angle 5, the measure of those is 180 degrees. Supplementary. 3 and 5 or 4 and 6. Those are consecutive interior. Alright, let's look at some examples. Identifying angles. The measures of 3 of the numbered angles are 120. Identify the angles and explain your reasoning. So here's 120. You can start any way you like. I'll start with what we just looked at. For example, alternate exterior angles. So the measure of angle 8 is 120 because alternate exterior angles. Alright. Then the measure of angle 5. Measure of angle 5 is 120 degrees because vertical angles. And 5 and 4 are alternate interiors. So the measure of angle 4 is 120 alternate interior angles. There we go. 1, 2, 3 other value of x using the properties of parallel lines. Okay, what do we know about these two? Well, we don't know anything about these two in particular, but we know about 115 and angle 4. Okay, so we can say angle 4 is also 115 degrees because vertical angles. Now that I know angle 4, I know these two are supplementary, so I know if I add those two together, I get 180 degrees. So the measure of angle 4 plus x plus 5 gives me 180. And I know what 4 is, vertical angles, so I can replace that with 115, and then I can solve. Add together 115 and 5, subtract 120, and x is 60. skip something here. There we go. Find the value of x. All right. We don't know necessarily anything about 136 degrees and 7x plus 9, but we know that 1 and 7x plus 9 are alternate exterior. So if we can figure out 1, we can find this one. So 1 is a linear pair with 136. And that tells me that these two add up to 180. Subtract from 180 and we get 44. So angle 1 is the same as congruent, which means their measure is the same. So I can set those two alike and say that the measure of angle 1 is equal to 7x plus 9, which means 44 degrees is 7x plus 9. Subtract 9, divide by 7. Boom, we found x. Alright, example 4. Prove that if two parallel lines are cut by a transversal, then pairs of alternate interior angles are congruent. Okay, when you read through something like this, I always recommend draw yourself a little diagram. Okay, let's draw some diagrams, see what they're talking about. We want alternate interior angles, so 1 and 2 are alternate interior. Okay, we want to prove that these two are congruent. Now next, write down what's given. We have parallel lines, and we are proving that 1 is congruent to angle 2. So draw a little diagram and write what's given and write what you're supposed to prove. Then we can make a proof. Alright, we're given that P is parallel to Q. We know that 1 and 3 are congruent. Corresponding angles theorem tells us that. And then 3 and 2 are congruent. The vertical angles, congruence theorem tells us this. And then, boom, transitive property of congruence, 1 has to be congruent to 2. And there you have it. Finally, let's look at a real-life example. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, measure of angle 2, right here, the measure is 40 degrees. What is the measure of angle 1 from which we are looking at that light? And how do we know that? Well, first off, we know that the rays of the sunlight are parallel. Alright, so we've got to start with what we know. The rays are parallel. Okay, and so we know measure of angle 2 and angle 1. Angle 2 and angle 1 are alternate interior angles. And since it's parallel, we know that the measure of angle 2, well, first are congruent. Angle 2 is congruent to angle 1 because alternate interior angles, and so we know that measure of angle 2 is equal to measure of angle 1. That is definition of congruence, and so we know that the measure of angle 1 is 40 degrees. And ladies and gentlemen, that's all for today. Check in next time for another fun lesson with a mastermind.